Hi friends, welcome back to yet another session on UML diagrams. Now let's time to look in detail what the state diagram is all about. A state diagram, also called a state machine diagram in the UML, shows the different states an object can be in. So now we are talking about a particular object. So an object can be behaving differently in different times. So this different behavior is called a state. So it can be in different states at different time. So we want to differentiate the various behaviors of an object and then show this on the timeline, and then transitions between these states based on some events or the conditions. So the behavior of the object changes from one behavior to another way only when some event occurs or some conditions are met. So that is shown through the transitions, and along the transitions the condition or the event name is written so that it is easier for us to understand that what made the transition from one state to another state. And it is mostly used to model the dynamic behavior of a system object or the class over time. So we are not talking about all the objects simultaneously, we are talking about behavior of one object, and just focus on it and see along the timeline, does the object change its behavior? If so, how? Each behavior becomes one state of the object, and the reasons for changing its behavior are the conditions or the events, and then there is a change, that means transition from one state to other state. All these are put on the paper in the form of a state diagram. So the key elements in the state diagram are the states, or the conditions or the situations in the life cycle of an object. That is, an object may be doing nothing, it's idle, or maybe processing something, or has completed its work, or something like that. And then we have transitions that shown by the arrows from one state to another state when some event occurs. Then we have a initial state, that is where the whole behavior of a particular object can be visualized, where it starts. So that's the initial state, which by standard is shown by a black filled circle, and then we have somewhere to end it, so that is shown by a circle with a dot inside. The events and the conditions are the labels on the transitions, like the payment received or fraud detected and all that. So when a payment is received, the state of the object changes from one state to another state, so that there is a arrow shown from that state to another state, and along the arrow label is given like payment received and so on. Now if we compare to the previous diagrams we had drawn earlier, how state diagram is different from, so if we just take a bird's eye view, can be easier to understand what makes this different from other diagrams. So first thing, we have started with the use case diagram. It talks about what functions exist in our system. Just a list of the functions that exist in our system are shown in the use case diagram. And then in the activity diagram we have shown the workflow, how the work flows from one step to other step and all that. And then we have a sequence diagram. This was talking about the interaction between the objects over time. Yes, with here also we are talking about time and objects, but the thing is, here we are talking about interaction between the objects over time, whereas state diagram is life cycle of a single object across the states. So one object life, how does it change from time to time? That is what is shown by the state diagram. Sequence diagram shows the interaction between the objects, whereas state diagram about one particular object and how the object's behavior changes from time to time depending on the external influences. Yes, how to draw? Yes, back to the same way starting point. That's we begin with our use case diagram. That's where these diagrams are to be created from. So let's have use case diagram. So pick a use case, then from the example from our fraud detection machine learning system, let us pick the use case detect fraud. So identify the entity to track these states. So usually state diagram is drawn for a single object, and here let us say the key entity is transaction. So define the possible states of the entity. So for the transaction object, the state may be not yet started, so it is idle, waiting for some transaction to take place, so it is waiting for some transaction, and once some transaction takes place it starts processing, so it is verifying the validity of the transaction and then verifies is there any fraud, so tries to detect fraud in that and tries to validate the transaction. Two things happen in parallel. Then it goes to the flag state if we find that the transaction is fraudy. So if there is suspected fraud in the transaction, then it reaches to a state called flagged, and then there is another state reviewed, that is checked by the fraud analyst. The fraud analyst will give the response, and that's what the state is reviewed. And finally, if it is if the transaction is good one, not a fraud one, then it is approved. If the transaction is fraud, then it is rejected. So finally it is going into the completed state. So it all begins with the idle state, then goes into processing, then if there is any fraud, then it goes to the flagged state, and from there it goes to the reviewer reviewed state, then completed state. There is fraud, then it is flagged. If it is not fraud, then it is approved. Whatever, it comes down to the completed state. Then the next step is to map these events triggers from the use case steps. So customer initiates the transaction. So from the idle state, it moves to the processing states. Then the fraud detection model runs. So if the transaction is clean, then it leads to the completed state. If it is suspicious, then it is shifted to the flagged state. Then the analyst reviews, and after the analyst reviews, then the state changes to reviewed and then completed. Then finally we draw these transitions, so each step in the use case becomes a transition between the states. So use case detect fraud, then state diagram. So in the use case it was called detect fraud, and in the state diagram we are calling it a transaction object. So we start with a start, then get into idle. From idle, if we get a transition initiated, it gets into processing. So from processing it gets into completed if there is no fraud found, or from processing it gets to flagged if fraud is suspected, then fraud flagged to reviewed state. So after the analyst reviews, because we can't just flag it saying that this is suspected, so it may be having some suspicious things in that transaction, so we are not yet sure, therefore we send this special cases to the analyst and then gets a review. So we get a review from the analyst, and then that once the review is available, then the state changes from the flagged to the reviewed, and then from the reviewed it goes to the completed. Here the case is closed. Now what is this analyst review and all that? So why it goes only when it is fraud suspected? Yeah, when you look at the transactions in overall sense, then hardly very few transactions are of fraud, and majority of them are uh, clean transactions, so don't have any problem with them. So majority of them we can just allow them But whenever we get a suspicion, then we stop there, get the analyst's views from a human, and then continue. So instead of making every transaction viewed by the human, only a few special cases can be forwarded to the human, and that is what we are trying to work on. So that is every case cannot be a fraud. So only some cases are suspected as fraud, not at, accepted as fraud, suspected as fraud, and then sent to the reviewer. And if the analyst says that it is clean, then it is allowed. If the reviewer said that it is a fraud, then it is rejected. So that's the lifetime of the object transaction, and then finally ends. So that's how it looks like. So whatever we keep on speaking makes no sense if we put them in the form of words and make no sense, but the whole whatever discussion we had earlier just can be put on one slide, and one picture makes whole thing clear. So as long as no transaction is initiated, it will be in the, as long as the transaction is not initiated, it will be in the idle state. When the transaction is initiated, it goes into the processing state. After processing, it finds there is a fraud, it goes to the flagged state. If there is no fraud, then it just directly accepts it and completes the transaction. If it is suspected fraud, then it will be flagged and it is sent to the analyst for the review, and the analyst will review and give the review report, and then will close the case. If it is fraud, then it is completed by rejection. If it is not found to be a fraud, then it will be cleared and completed. So that's about the use case diagram. That's about the state diagram from the use case diagram. So another use case diagram with more details, like online ordering, food ordering system, where we are talking about order objects. So we have so many different states are there. Another example would be an online food ordering system, wherein it begins here, ends here, and you can follow the arrows. So if we are the first time getting into this system, then we need to register it. If we are already registered, then we can log in, and then we can search for the food, and then search the items, and then view, if it is found, then view the items, then select the items, and if you are interested, then add to the cart. If you are not interested, then continue your search, view various items, and then keep on adding to the cart. And once your selection part is over, then we proceed and then view the shopping cart for the final. And if there is any updation required, then it is possible to update it, and finally get into create the final order, and get the details, confirm it, make the payment, and then finally log out. So that's a state diagram, for overall state diagram for the food ordering system. That's online food ordering system. So that's about the state diagrams. Thank you.